Welcome. In this presentation, we'll cover some of the common usages of this new syntax in Java as of Java 1.5 called generics. Java has always maintained a philosophy of strong data type matching. We've seen that in some of our examples, and the convenience of it is that we can push some of our more common syntax type errors toward the front of the development process, namely discover them at compile time rather than discover simple errors at runtime. We've run into a problem with that, however. Collection objects, for example, as we've seen, actually store data type object, seeing as how object is at the top of the inheritance tree of every class in Java. Object then can be any data type whatsoever, and it confounds the philosophical goal of data type matching. Generics can help us get around that problem and to specify data types at runtime. Let's look at this example for the use of generics and as it might be applied to a collection. On line 7, we're declaring a new array list. Notice the syntax. There's angle brackets after the list data type, and it indicates a string. What we've done is that we've told the compiler and our runtime environment as well that this list must contain strings. We also use the angle brackets and string as an added element in the call to the constructor. You'll notice that with new array list angle bracket, string angle bracket. Now we're free to go ahead and on lines 9 through 13, you can see that we're just adding strings to that array list. If we should try to use something else that is not a string, our compiler will complain and tell us that we're trying to do something inappropriate. We can go ahead and simply create and work with this array list, similarly to what we had done earlier. The only real difference is on line 17, when we're creating that iterator so that we can move through the entire list of objects, notice that we're also using the generic notation there to declare the iterator. Now we can move through the list of strings. Notice where he's using his string buffer to just simply concatenate the strings together for all of the words we've placed in that collection. And then he just prints the result. Right. Also, you can use, and we haven't really talked about this too much, but collections can also be used in a simple way with the for each loop. And notice here that all he's doing in the for each loop is to take the string list and iterate through it. And he's not even creating an iterator in this case. He's actually using the list itself as a source for obtaining the objects. Also, take special note, because we're going to refer to it a little lower. Take special note in how we're using those strings. What I'm doing is assigning the elements in ls directly to string. That's what's happening in the between the parentheses of the for loop. If I were not using generics, the syntax here would be impossible, simply because a list would at that point only store objects. I would have had to explicitly cast from object and downcast or upcast it, downcast it to a string. To illustrate that point, let's look at the code that we see here. He's using just a plain ordinary old array. Notice no generics as shown on line 30. Once again, he's adding strings to that array, or to that array list. Now, he creates his string buffer as before, and he creates his iterator. The problem comes in when he's working, when he tries to use those strings to add things to his string buffer. Notice on line 42 that the object that we are pulling from that collection has to be explicitly cast using the string data type so that it can be added into the string buffer. The reason, again, is because the only thing we know of at this point is that list contains objects. Now, this opens us up to possible class cast exceptions. If I should store something other than a string in the list, it would be totally okay as long as it's not a generic, and that could mean that the logic that we see on lines 41 through lines 44, we could get class cast exceptions in there. And the only way we'd know about it would be at runtime. By adding the generic, if I did attempt to add something to that list other than a string, I'd catch it at compile time. Right. Okay, so we can see that generics do in fact give us a nice convenience. Also, in your readings, you've noticed that you can create your own generic types. Those can be valuable when we want to create a tightly type-matched object, but we really don't want to know what the type is until runtime. This new syntax really opens up a sense of flexibility to type matching while still retaining its value. So we get our cake and eat it too. Your next feat is to work with generics in your exercise. I'll be back after you're finished with your exercise and we can go through the solution. Have fun.